Fractals are some of the most beautiful and mysterious patterns in mathematics. They can look incredibly complex, yet many are created from very simple rules. In this video, we'll explore what fractals are, how they work, and why they appear both in mathematics and throughout the natural world. Take a pattern and zoom in. Now zoom in again and again. With most shapes, things eventually smooth out. But fractals behave differently. The structure keeps repeating and new details continue to appear. No matter how far you zoom, the pattern never truly ends. Now take a look at this Romanesco cauliflower. Notice how each small cone is made up of even smaller cones, and these are made up of smaller ones still. No matter how close you look, the same pattern keeps repeating. This is called self-similarity, when a structure looks similar at different scales. It's one of the key features that defines a fractal. We begin with a simple triangle. This is a step 0. In the next step, the triangle in the center is removed, leaving 3 smaller triangles. The same rules then apply to each of the other triangles, removing their centers as well. This process repeats at every step. Even though pieces are being removed, the pattern becomes more detailed and increasingly complex. Fractals are not just mathematical ideas. They appear throughout nature. Tree branches divide into smaller branches, and rivers split into smaller streams. Lightning spreads in jagged, repeated paths. Even the structure of your lungs follow a branching pattern. These fractal-like shapes allow nature systems to grow eventually and fill space in a very effective way. Fractals also help us understand irregular shapes like coastlines. If you measure a coastline with a large ruler, you get one value, but if you use a smaller ruler, you capture more detail, and the measure length increases. This shows that some shapes do not have a single well-defined length in the usual sense. This image shows a fractal pattern with incredible detail. As you zoom in, new shapes continue to appear, spirals, branches, and smaller versions of the larger pattern. The closer you look, the more detail you find. Unlike simple shapes, fractals never become smooth. No matter how far you zoom, the complexity continues without end. Fractals are more than just interesting patterns, they are powerful tools. Scientists use fractals to model complex natural systems, from cloud to mountain ranges like the one shown here. In computer graphics, fractals help create realistic landscapes and textures. Engineering also uses fractal designs in areas like antennas and signal processing to better understand and work with complex systems. Fractals like this one are created using simple mathematical rules. A basic rule is applied repeatedly, with each step building on the last. As the process continues, intricate patterns begin to emerge. What starts as a simple idea grows into something highly complex. I realize in this short video I just scratched the surface of the world of fractals, but hopefully it sparked your interest in this fascinating subject. Be sure to subscribe for more math and physics insights. Thank you for watching.